Again, guys, let's continue with this section of the functions topic. In this third section, we will start by explaining or trying to understand what it means gradient, and then we will define it mathematically. Okay, we will derive the gradient formula. That is, come up with a formula that we normally use to calculate gradients, and with that formula we will then conduct some calculations, determine gradients for different lines when we are given specific kinds of information. After that, we're going to contrast gradients, that is, look at what it is that is common for the gradient of lines that are parallel and what we know about gradient of lines that are perpendicular. Okay. Finally, we will rate the gradient of a line to the angle it forms with the x-axis. This is a bit extended for students who've not studied trigonometry before. If you've not done trigonometry, don't worry about that last part. But if you know what trigonometry is and you've studied the basic trigonometric ratios, sine, tan, and cosine, then we'll see how the gradient of a straight line is related to the tangent of the angle it forms with the positive x-axis. Okay, so let's begin then. Try to understand what we mean by the gradient of a line. Normally, when somebody mentions gradient, the first thing that comes to my mind are hills, mountains and hills like that, and how people climb them, in particular how steep a mountain can be, as you can see there. So the term steepness comes to mind anytime somebody mentions gradient, okay? The steepness of the side of a hill, okay, or the surface of a rock, as you can see there, right? The steepness of one part of the rock, such as that one there, might be different from the steepness of another section there, like that's slightly less steep, and we even have another one there. So when we look at the steepness of the side or the face of a rock or the face of a hill, the idea of steepness kind of brings to mind what we mean by gradient when we discuss this in the mathematical context. Okay, so I want us to think of the idea of gradient by first of all looking at the idea of steepness of lines. Okay, so let's see. We're going to look at a number of lines here. I think I've drawn 4 lines here, and I want you to pause the video and think about the questions that I'm posing right now. Okay, the first question then is, which of these lines would you say is the steepest? Okay, and which of the lines do you think is the least steep? Which 2 lines would you say have about the same kind of steepness? And lastly, how is the line number 4 there, the pink line there, how is it different from the other 3? In what way is line number 4 there different from the other 3? So please pause the video, and perhaps you want to write a few lines, what you think the answers to these questions are. Put it ready so that then we can move ahead. Okay, so if you've done this, if you've answered the questions, I'm hoping that you've probably determined, based on your understanding of steepness, that line number 1 is perhaps the most steep. Okay, that is the orange line there is the most steep. Okay, it's the most inclined. And the one that is least steep is line number 3. The green line there should be the least steep. Okay, if you go by understanding of steepness as we know it in spoken English language. Which 2 lines have about the same amount of steepness? And the correct answer here would be line number 4 and line number 2. All right, so these 2 lines, that and that, have about the same kind of steepness, except one is facing the opposite of the other. Okay, so the blue line there and the pink line have about the same amount of steepness. Okay, in other words, if you were to climb the sides of the mountain, you're probably going to expend the same amount of energy to climb the same amount of height. Okay, so they have about the same steepness. And how is line number 4 different from the rest of the lines? Well, when we want to talk about steepness in mathematics, we come up with a convention. So we decide that we always record steepness starting from the left, moving towards the right. So if we were to start at any point on one of those lines and move towards the right, you will notice that for all the other lines on your way towards the right, you are actually rising, you're actually climbing. But for line number 4, we've started from the left, so that means we are somewhere there. As you move towards the right, you are actually dropping. So the pink line is different from the other 3 in that it is the only case where you are actually coming down or dropping as you move towards the right. Okay, so by convention, we must always move towards the right. And in the case of the pink line, it is the only case where we are coming down towards the ground as we move towards the left. Okay? Okay. So as we move towards the left like that, you can see that on line number 4, it's the only case where the line slopes downwards as you move to the right. Okay, let's move on there now. Okay, we want to quantify the idea of steepness. Okay, so we saw there that one of the line was steeper than the rest. Okay, let me take you back. We saw there that line 1 was steeper compared to line 2 and compared to line 3. But can we quantify this thing that we refer to as steepness? So in order to quantify steepness, we use a number symbolized by letter M, or in the Swedish program, that would be letter K. Okay, it's a real number, and it represents the degree of steepness and also the direction of steepness. When I say direction, I mean that as we move to the right, either the line is climbing or it is sloping down. So if it is climbing, then we say it has got a positive steepness. If it is falling, we say that it has a negative steepness. Okay, so we use a real number to represent the degree and direction of steepness. Okay, here is an example of what I'm talking about. So I can pick 2 points like that. If I move one step, if a line is such that a movement of one step in the positive x direction or to the right results in, say, 3 steps climb, okay, like that, then we can say that this line has a steepness value of 3. Okay, a steepness value of positive 3. The positive means the direction of steepness is positive, and the amount, the magnitude of that steepness is 3. Okay, any other line that is parallel to our blue line there will be obeying the same rule, in that a step of one step in the positive x direction will result in 3 steps in the, if you pick any point at all. So starting from here, for example, if I want to climb like that, a movement in the positive direction of 1 step results in a movement of 3 steps in the y direction. Okay. Here's another example, a line with a different kind of steepness. So in this case, we move 1 step in the positive direction, results in only 1 step in the y direction, and we say that this line has a steepness value of positive 1. Positive again, because as we move towards the right, the line is climbing. All right. Here's another example. Again, of course, any other line that is parallel to this line will obey the same rule, and so all those lines have the same steepness of positive 1. Okay? Here's another example. In this case, as a movement of 1 step in the positive x direction, resulting in half a step in the y direction. So clearly, whatever I'm going to draw here must be aligned with a steepness of positive 0.5. Okay, to see it clearly, if 1 result in a half, then 2 must result in 1 full. Okay, like this. All right, like that, which is to say that a line drawn through this will have, okay, so we are having two steps resulting in one step, but one step resulting in a half a step. So this line has a steepness of a half, okay? And any other line that is parallel to this line will have the same kind of steepness. So the steepness is a measure of the degree at which the line is sloping upwards or downwards. Here is the last one, I believe. Okay, so in this case, a step, a movement of one step in the positive x direction, resulting in a drop of two steps in the y direction. Such a line is said to have a steepness of -2. Okay, so in this line, as you move towards the left, the line drops downward. So we say it has got a negative steepness. Okay, so this is how we quantify the idea of steepness of a line or of a surface. Okay, and any line that is parallel to our blue line will have the same rule or will have the same level of steepness. Okay, the mathematical name for steepness of a line is what we refer to as gradient or slope of a line. Okay, so we can see that line 1 there, it has got a positive kind of steepness because a single step in the x direction will result in two steps in the y direction. Okay, if you make one step this way, it results in a movement of two steps in the y direction. And so we say this has a positive steepness of magnitude 2. All right, or as we say, the steepness is another name for gradient, okay? Or in mathematics, gradient is the term we use when we are referring to steepness. So we say the gradient of line L1 is 2, okay? Similarly, for line 2, if we move one step, we move down, it's about a third. Okay, so that means we must move 3 in order to complete one step in the y direction. So line 2 has a steepness or gradient of negative a third or negative 1/2. Negative because as we move towards the right, the line is dropping. Okay, or sloping downwards. So we say line 1 has a gradient of 2 and line 2 has a gradient of negative a third, like that. Okay, why do we say that? Let's just remind ourselves again. The gradient is positive if the line rises in the positive direction. So as we move in the positive x direction, the line is rising in the y direction. Okay, so the height is increasing like this. So for line number 1, as we move in the positive x direction, in other words, from left towards right, so we move like that, the line is rising. So we say this line has a positive gradient. Okay, we say this particular one has a positive gradient of 2. On the other hand, in the second case, the gradient is negative if as we move to the right, the line is dropping like that. So as we move to the right, the line is falling or dropping. We say that the gradient is negative. So I hope this is clear. Let's see how we define gradient mathematically. Based on what we've just seen there, we said we were talking about moving one step in the positive x direction and checking how much we've risen. Another way to find this directly is just to say how high do we climb or how high do we drop for a unit movement in the x direction. So when we define gradient, we think of that, okay? And by definition, using mathematical definition, we say that the gradient of a line is the rate of change in the y direction with respect to the change in x direction. What do I mean by this? Okay, so that's the mathematical definition of gradient. All we need to do then to define this is to take 2 points on a straight line, okay? We'll call that point A with coordinates XA and YA. And let's have another point there, B, with coordinates XB and YB. All right. In moving from point A to point B, I move a certain distance in the X direction, and that is normally referred to as the run. Okay. And in moving from A to B, and therefore covering a certain distance, xb minus xa, based on previous video, we have also risen above this point at that distance there. Okay, so by moving this, we've also risen a height of yb minus ya. So in moving from A to B, we have risen a distance that much, and that distance is referred to as the rise. Okay? And so if I know by how much I've risen for that run, I can find the gradient, because the gradient is the rate. In other words, taking the change in y, this rise here is the change that has occurred. When I move from this point to this point, there is a change in height in the y direction, and is found by taking the final y position, subtracting the initial y position, which is ya there. Okay, so change in y and divide by the change in x. Okay, let's see. So in symbols, we would write that the gradient, whose symbol is m, is the change in y, which is that rise there, divided by the change in x, which is the run. So often we just say rise over run, if you can remember that. And how much is that rise? The amount of rise, as we already know, is the value of yb, the coordinate of y at the last point there, subtract the y coordinate at point A. So we will say that is yb over that, and the run is going to be xb minus xa. xb, this point here, subtract that point. And so this is how the formula we use to determine the gradient of a line based on the definition of what it means, the gradient of a line. Okay, let me just write it properly. So we say the gradient m is the change in y over the change in x, like that. That is the formula we use to determine the gradient of a line. Okay, let's check your understanding with the first example. Find the gradient or the slope of the line below. Each square grid is of unit length. So this line is on a square grid like that, and the side of these squares is 1 unit. Okay, so what's the gradient of that line? You may pause the video and try it yourself, and then check my solution. Okay, pause the video and do it. Okay, assuming you've done so, what we need to do is to pick 2 points whose coordinates we know. So we can't just pick any point. Since we've been given a grid there, we want to select points whose coordinates we are confident of. For example, I know the coordinate of that point there. I know the coordinate of this point, that point there. So we just need 2 of them. In sciences, we insist that you always take the 2 points to be as far apart as possible. Okay, so let's pick 2 points. That's going to be my first point. You can see the coordinates are 1. We said 1 square is 1 unit. So 1 by 2. So the coordinates are 1, 2. And we can pick another point there whose coordinates, from what I can see, is 5, 4. Please check that that is true. So coordinates of 5, 4. If we're going to find the gradient, we must use the formula gradient is change in y over change in x, which is to say, take the final value of y there, subtract the initial value of y there, whatever you get, divide by xb minus xa, right? What are we saying? So the gradient is yb minus ya over xb minus xa. Sometimes we call this position 1 and that position 2, so that you say y2 minus y1 over x2 minus x1. Notice that if this is yb, then this has to be xb. You can't have yb there and xa on this point, all right? So final minus initial, or initial minus final, both ways. So you could start with ya minus yb, but then this must also be xa minus xb. So if we substitute in the values, then yb, in other words, the y coordinate of point B is 4, the y coordinate of point A is 2, so we're going to have 4 minus 2 divided by the x coordinate of point B is 5, subtract the x coordinate of point A, which is 1. Okay, so we are going to have then 4 minus 2 over 5 minus 1, and that should give us a gradient of, what's that? should be a half. 2 over 4, which is a half. So the gradient of that line there is a half, and it makes sense because a movement, a horizontal movement of one step there results in half a movement there. So it makes sense that the gradient of this line is a half. Okay, let's see the next. Checking your understanding. Second example. Find the gradient of each line. Okay, so now we have a number of lines there, and I want you to pause the video and try to find the gradient of each of them. Again, remember, it's a square grid. Each square represents 1 unit square. Okay, so each side of the square is a single unit. So one more time, we will start with the first one, line L1 there, the blue line. We need to pick 2 points whose coordinates we know, and I think we know the coordinate of that point there. I think we know the coordinate of that point, and a few others, I think this point here, and so on. So if we pick 2 points, then pause the video, of course, and if, assuming you've done this, we pick 2 points, we'll do the first one, and then the other ones I'll just give you the answers. You can try them out yourself. So if we pick 2 points on the line L1, the blue line, I've picked 1 point there. The coordinates of that point are -5, 5, if you check carefully. All right, and we pick another point. If we pick another point there, the coordinates are 3, 3. Okay, coordinates of that point there are 3, 3. And so if we're going to find the gradient of that line, we must say gradient is change in y over change in x. Okay, from the formula y2 minus y1 over x2 minus x1, or yb minus ya over xb minus xa, same formula. The final point is here. Remember, we are always moving in the positive x direction, so that's the final point, and that's the initial point. So therefore we have 3 for y, for the numerator there, 3 minus 5 there, and for the denominator, which is x2 minus x1, we have 3 minus -5. So we have 3 minus -5 there. The numerator gives us -2, and the denominator gives us 8. Okay, so -2 over 8 is -1/4. So we know the gradient of line 1 has to be -1/4. So in the same way, I would like you to try the others, and if you have paused the video and done them correctly, I would expect you to get the following values. So for line 2, which is the vertical, what color is that? That would be lime. The gradient of that line is infinite. Okay, why is it infinite? Okay, line 3, you should get a gradient of 2 over 3. For line 4 is the purple line, horizontal line number 4. The gradient of that line is 0, and the gradient of line 5, you've done it correctly, is 4. Okay, let's move on now. Still checking your understanding, and the question is to find the gradient of each line. Now this time we don't have the grid, however we have enough information to help us find the gradient of all the lines. Needless to say, line 4 is horizontal and line 2 there is vertical. Okay, so find the gradients of those lines. For the other lines, there are enough coordinates given. So the coordinates of this point, for example, are -4, 0. So we know the coordinates of that point, and we know the coordinate of this point. So we can find the gradient of line 3. In the same breath, we can find the coordinates of the blue line 1, because we know the coordinates of that point there, and we know the coordinates of this point. The coordinates here are 0, -5. Okay, the coordinates here are 0, +5. So we can use this point and that point to find the gradient of this line. Okay, we can use that point and this one to find the gradient of this line. Okay, so if you have done this correctly, you've paused the video and you've done this correctly, you should end up with the following values. So for line 1, which is the blue one, you should get that the gradient is -5 over 4. For line 2, you should find that the gradient is infinite. For line number 3, the gradient is 2 over 3. Line 3 is the orange one. For line number 4, the gradient is 0. You should already see something happening, some pattern. And for line number 5, the gradient is negative a half. So obviously, lines for which a movement in the positive x-axis results in a drop, like line 1 there and line 5, must have negative gradient. Okay, so the direction of those two gradients are negative because of the nature of the line, the inclination of that line. Okay, let's move on now. Okay, what do we know about gradients of horizontal and vertical lines? So if you did this question correctly, you can see that for the gradient of the horizontal line there, we found a gradient of 0, and the gradient of the vertical line here is turning out to be infinite. And we saw that with the previous question as well. Okay, so what do we know about the gradient of horizontal and vertical lines? And in order to answer this question, I am putting up a question. Show that the gradient of a horizontal line is always equal to 0. So if a line is horizontal, then by definition the gradient is 0. And if a line is vertical, then by definition the gradient is always going to be infinite. Can we show this? Okay, let's see how to go about that. Okay, pause the video and try it out. You don't need to draw an elaborate diagram. You just need to demonstrate that it is really going to be 0 or infinite like that. Okay, so what I will do here is to put the grid there, and we will draw a horizontal line. Now, what we know about horizontal line is that the y coordinate is always the same. So if I pick any 2 points on this line, or any point at all on the line, pick any 10 points or 100 points, the x-coordinate may change, but the y-coordinate always remain the same. So let's pick one for example. I've picked a point there with coordinate negative 4, 2. Okay, if I pick another one there, it's going to be 3, 2. So the x-coordinate is changing, but the y-coordinate remains the same, that is 2. Okay, because of that, when you use the formula gradient is change in y over change in x, the change in y is always going to be 0 because it's always going to, in this case, it's going to be 2 minus 2. So the numerator is always going to be 0. So if I write this, this is always going to be 0. So 2 minus 2, and this is going to be over 3 minus, say, negative 4. And this is 0 over 7. 0 divided by any number is always 0. So provided a line is horizontal, the y coordinates are always going to be the same, so that when you subtract the numerator, you're always going to get 0. Okay? And therefore the gradient of the line is always going to be 0 if that line is horizontal. Okay? So if a line is horizontal, for any horizontal line, y2 is always equal to y1. So for horizontal lines, YB is YA, okay? And therefore, YB minus YA is always going to be equal to 0. So it doesn't matter whether there is an X value in the denominator. Because of that, the gradient M is always going to be 0 over XB minus XA, and this is always going to be 0. So keep this in mind. It doesn't matter where that line is, provided it is horizontal, whether it's below the x-axis or anywhere above the x-axis, the y-coordinates are always going to be the same. Okay? What about a vertical line? Okay? If a line is vertical, such as that one, then, so we saw that for horizontal line, the y-coordinate is always the same, no matter what point you pick on the line. For a vertical line, the x-coordinate is always going to be the same, no matter where you go. All right? Whatever point you pick, the x-coordinate is always going to be the same. So in this case, that's negative 2, and that's negative 2. So anywhere here, the y-coordinate will change, but the x-coordinate is always going to be the same. So that when we use our formula there, in this particular case, for example, then we have, so in this case, we're going to have y2 is that one there, 5, minus y1 is negative 1, okay, which is going to give me 6, but the denominator is always going to be negative 2, minus negative 2. So that's negative 2 plus 2, this is going to be 6 divided by 0. Any number divided by 0. So now we're going to always have the denominator turning out to be 0. A number divided by 0 is undefined, and we represent that using the symbol infinity. Okay? And so this is the reason why every vertical line has infinite gradient. Okay? So it doesn't matter for a vertical line, if the line is vertical, if line is vertical, then we know xb will always be equal to xa, and therefore xb minus xa is always going to be 0 in the denominator, and so we will always have an infinite result. And so when we assign gradients to lines, anytime we assign gradient to lines, remember gradient refers to the number that represents or represents the size of steepness. Okay, so whenever we represent gradient, remember that a horizontal line has a gradient of 0, while a vertical line has an infinite gradient. Okay, every time. Let's move on again. Now we look at gradient of parallel lines. Already you should have a clue because we mentioned it earlier. If two lines are parallel, what is it that we know about their gradients? Okay? If the gradient represents steepness, then if two lines are parallel, there is something about their steepness. So let's look at this line. For example, a movement of one step in the x direction results in a movement of 3 steps in the y direction, so that if we join this with a line, okay, so a single step in the x direction followed by 3 steps in the y direction will give us a line which has a gradient of, the gradient is going to be 3, positive 3 in this case, because the line is rising. So this line has a gradient of 3. Okay, because a movement of one step in the x direction results in a movement of 3 steps in the y direction. Any line that is parallel to this line will have the same rule applying to it. Okay, so we know the gradient of this particular line is 3. If we draw any other any line parallel to this line, like those 4 there, then you can see that the same rule applies. Okay, so look at the dotted line I'm drawing now. So for the first one there, you can see that you have one step resulting 3 steps. If you pick another point, it should repeat itself the same way. If you look at the second line there, the same applies. Look at the third line on the other side of it, and the same rule will apply. Because of this, we conclude that parallel lines have the same gradient. If two lines are parallel, then their gradients are always going to be the same. Okay, this is just for you to pick up, right? Parallel lines will have the same gradient. Here is an example in the case where the line is dropping as we move to the left. Okay, so the first line there has a gradient of negative 2, and we can conclude that any line that is parallel to it will obey the same rule. If I pick any point here and move one step, I will result in 2 steps down, like that. Okay, and so starting there, you should see the same rule is applying. The gradient is negative 2, and this is repeated everywhere like that, or somewhere else like that. Okay, look at the other lines as well, and you notice that a single step in the positive x direction results in 2 steps down the negative y direction. So all the parallel lines have the same amount of gradient, or the same amount of steepness. Okay, we will write that as a statement, as a mathematical statement, that parallel lines have the same gradient. If two lines are parallel, then their gradients are always going to be equal. And this is how we would write it mathematically, that if L1 is parallel to L2, then M1, that is the gradient of the first line, must be equal to M2, which is the gradient of the second line. Keep that in mind. Now let's talk about the gradient of perpendicular lines, but before I do that, now let's talk about the gradient of perpendicular lines. I took the opportunity and made 2 perpendicular lines on Geogebra. I can turn this around. I can pick a point and move this around, but the 2 lines will always remain at 90 degrees to each other. So these are perpendicular lines. Okay, the angle between them is always going to be 90 degrees. Now if I pick, so there are 3 points on these lines, and I want us to use that to find the gradient. And if we find the gradient and then compare the results that we get. So the gradient of let's start with the bluish line. The gradient of that line, I think I can do it here. So the gradient M is going to be change in y over change in x. So we will pick that point and that point there. This is going to be the y value is y2 minus y1. So the y value here is -2 minus the y value there is -8. Okay, and we're going to divide that by the x value here, which is 3, minus the x value there, which is -1. This gives me a value of 6 over 4, which is 3 over 2. So the gradient of this line is 3 over 2. Of course, I don't have to do this calculation. Because we are given the grades, it is actually possible to see that if you move 2 steps in the positive x direction, you end up moving 3 steps upwards. So it is 3 to 2. Okay, so that's why the gradient is 2. If we do the same thing for the orange line there, now we pick that point and that point, we should be able to see now directly. I'll do it a bit faster now. So let's call that line 1. Then our line 2 now has a gradient of -2, because that's the last point, divided by 3 over 3 minus -3. Okay, so this is +6, which is the same as -2 over 3. So when the gradient of one of them is 3 over 2 here, and the gradient of the second one is -2 over 3. Okay, now I want us to do the same. I can change the values. I can put this aside. This is 3 over 2, and this is -2 over 3. Please keep this in mind, or write it down somewhere, because I want you to see the pattern. So what we have actually seen is that if one of the gradient, I'm going to write this here. So when one of the gradient is 2, let's say gradient of line 2 is 3 over 2, the gradient of the other line is -2 over 3. Okay? Now I can go ahead and change the position of my lines like that. I'm just rearranging it, changing orientation like that. Now I have those points. Again, this angle is 90 degrees. Okay, the coordinates of this point are 3 minus 2. Of course, I can change it. I can move it around. I could move it, say, somewhere there. Perhaps move it a little. Doesn't matter really. The idea is any point you pick should be able to give you the same result. Okay, so let's just pick that point. Should be good enough, right? So if we pick that point again and look for the gradient, I can tell, you can check it out later, but I can tell the gradient of this line is 3. Now the gradient of one of the lines, line 2, is 3, and the gradient of the other line is clearly -1/3. Okay, you can perform the calculation. The gradient of the other line is going to be -1 over 3. Okay, so I can move this again and again and check the gradient of the one of the line, and the gradient is of the line that is perpendicular to it, and see what happens. And so using the Geogebra app, these are the results we found for 2 sets of lines that are perpendicular. I want to give you 3 other lines that I want you to try out. Find the gradient of the blue line and the gradient of the orange line, and then we are going to make a comparison at the end. Okay? So here is the first one that I want you to try. You will put your values for the orange and for the blue lines as follows. So find the gradient of that. Put your result for the blue line there. Okay. just below that, and your value for the orange line there. Okay, what do you find for the gradient of the blue line, and what do you find for the gradient of the orange line? Okay, if you've done so, here is the second one. Okay, so that's a second line. So just below the results you find there, put another line for the gradient of the blue one and the gradient of the orange one. They are actually three, so this is the second one. Let's see the third one. Okay, here is the third line. Okay, what's the gradient of the blue line and what is the gradient of the orange line? If you've done this correctly, then these are the results that I find. Okay, so I put the results in a table. Let's hope that you got the same. Hopefully you've also kept the gradients of the two lines that we started with using Geogebra earlier. So what values do we get? When the blue line has a gradient of 4/3, my orange line gives me a gradient of -3/4. When my blue line has a gradient of -1/5, my orange line gives me a gradient of 5. And when my blue line gives me a gradient of 3/4, my orange line gives me a gradient of -4/3. Looking at the pattern, you should be observing a pattern. Please pause the video and think of a pattern that is evident. Okay, what do you notice about that line, the gradient of that line, and the gradient of the line that is perpendicular to it? Is there a relationship between these two gradients? Okay, pause the video and think about it, and that is the same. Whatever you see here, the same rule here is also applying to these two and is also applying to those two. Okay, take a moment and think about it, and if you have thought about it, you should notice that if you take the gradient of that, flip it over and turn it, make it negative, you get the gradient of the line that is perpendicular to it. Okay, same as this. If I take this and flip it, I get -5/1, which is just -5, and then I take the negative of it. Okay, I'll get 5. If I take that, flip it, and then take the negative of it, I will get the other line. So if two lines are perpendicular, then the gradient of one of them is, we say, the negative reciprocal. Reciprocal means flipping. So the negative reciprocal of the gradient of the first one. So if line 1 and line 2 are perpendicular, then the gradient of line 1 must be the negative reciprocal of the gradient of line 2. It's the negative of the number you get when you flip the other gradient. Okay? Like that. But another way of putting it is that if these two lines are perpendicular, then if you take the gradients and multiply together, you always end up with -1. Check it out. So if I take this and multiply by that, I always end up with -1. If I take that and multiply by that, I always end up with -1. So if two lines A and B are perpendicular, then MA times MB is always equal to -1. This information is very, very useful, not only in this topic, but later when we are studying calculus. Okay, so please keep it in mind. It's really, really important. Let's write this down. So if two lines are perpendicular, then the product of their gradients is always -1. Okay, written mathematically is if line 1 is perpendicular to line 2, then the product of the gradient must always be -1. Okay, and another way of saying that, which is what I started with in the first place, is that if two lines are perpendicular, then the gradient of one is the negative reciprocal of the gradient of the other. Okay, the gradient of one line is the negative reciprocal of the gradient of the other. If two lines are perpendicular, then the gradient of line 2 is the negative reciprocal flipping of the gradient of the first line. Okay, I hope you got that. Finally, before we look at your understanding of what we've discussed, finally, I want us to talk about the angle that a line makes with the positive x direction. Okay, if we know the gradient of a line, then it is very easy to find the angle that it makes with the positive x direction. For example, here is a line. Okay, so that line there has a gradient of 3. Clearly, one step in the x direction results in 3 steps in the y, positive 3 steps in the y direction. So the gradient of this line is 3. If we know the gradient, we can find the angle that the line makes with the positive x direction going this way. So the line is going like that, so it makes an angle here with the positive x direction, like that. So if we wanted to find that angle theta there, then all we need is the gradient of the line. Okay, and how do we know that? Well, by definition, the definition of gradient turns out to be the same as the definition for the tangent of an angle. The tangent of an angle is defined as the ratio of the opposite to the adjacent. For those who've done a bit of trigonometry, I hope you'll understand this. If you haven't done this, don't worry, you'll come to it shortly. Okay, so by definition, the tangent of an angle is the opposite side for a right angle triangle, opposite side to that angle divided by the adjacent side to that angle, like this. So you can see the triangle I've just drawn here, that triangle here. Okay, let me do that again. I'm shading that area of the triangle. So that region that I've shaded there forms a triangle. Okay, so if that angle is theta, then this side here is called the opposite of the angle, and that side there is the adjacent to the angle. So by trigonometric ratio definition, we know that the tangent of angle theta is the opposite side divided by the adjacent side. Okay? So because of that, and remember that is also the definition of gradient, rise over run. So gradient is the same as the tangent of the angle that the line makes with the positive x-axis. Okay, for that reason, we can just say that the tangent of the angle, which is opposite over hypotenuse by definition of basic trig identities, is also rise, because that's the rise there. Okay, the opposite is also the rise. The adjacent is also the run. And so the tangent of the angle is equal to the gradient of the angle. So if I know the gradient, I can easily find the angle that the line makes with the positive x-axis. Okay, so tan theta then is equal to m, and I can find the actual theta by finding the inverse of the tangent. Okay, so we can say now that the tangent of theta is 3. So theta is equal to the arctan, or the angle whose tangent is the tan inverse of 3. If you use your calculator to solve this, you will find that the value of theta is 71.6. That this is to 3 significant figures. Okay, so we can use our knowledge of the gradient of a line to find the angle that the line makes with the positive x-axis. Okay, all right. Let's now check our understanding. Here is a first example. Okay, the lines L1, L2, and L3 have gradients of 0.5, -2, and a half respectively. That is, the gradient of line 1 is 0.5, the gradient of line 2 is -2, and the gradient of line 3 is a half. Here are the questions. State the pair of lines that are parallel and a pair of lines that are perpendicular. Any pair of lines that are parallel and any pair of lines that are perpendicular. Part B says to find the angle that line 2 makes with the positive x-axis and that line 3 makes with the positive x-axis. Question C says to show that the lines stated in A part 2, the lines that you stated were perpendicular, you need to show that in fact they are perpendicular. Show by calculation or prove by calculation that those two lines are in fact perpendicular to each other. Okay, so let's answer this question. Of course, you can pause the video and try it out first before you see my solution. Also, even as I complete one part, you can always pause and see if you can now handle the part B and so on. Okay, so let's look at this. Assuming you paused it and you did your own solutions, here we start then and solve this. So let's start with part A. State the pair of lines that are parallel and the pair of lines that are perpendicular. So by definition, we know that two lines are parallel if their gradients are the same. So which which of the three lines have the same gradient? And of course, the answer is line 1 and line 3, because 0.5 means the same thing as a half. So line 1 and line 3 have the same gradient. So we can conclude that line 1 and line 3 are parallel. Okay, here's the answer. Okay, so to part 1, parallel lines have equal or same gradients, and for that reason, from the information that is given, we can conclude that the gradient of line 1 is the same as the gradient of line 3, and so line 1 is parallel to line 3. Okay, what about part 2? Part 2 is asking which pair of lines are perpendicular. All right, now if two lines are perpendicular, let's go to B. If two lines are perpendicular, then the product of their gradients must be equal to -1, or the gradient of one is the negative reciprocal of the gradient of the other. Okay, if you've done so, you should be able to see that we have two choices here. Okay, so first, lines are perpendicular if their product of their gradients is -1, or if one is the negative reciprocal of the other, talking about gradients. Okay, and so clearly, if I take line 1, the gradient of line 1, and multiply by the gradient of line 2, so 0.5 times -2 is going to give me -1. So clearly line 1 and line 2 are perpendicular. Similarly, if I take line 3 and multiply by line 2, that is 0.5, which is line 2 and 3, so -2 multiplied by a half, that also is going to give me -1. And therefore, line 1 is perpendicular to line 2, or if you like, you may have chosen line 3 being perpendicular to line 2. So line 2 is perpendicular to both line 1 and line 3. Okay? All right? If you multiply those, you get -1. All right. Line 2 is perpendicular to line 1, and line 2 is perpendicular to line 3. So if you picked line 2 and 1, there you would be right, or if you picked line 2 and line 3, you would still be right. Okay, that was the solution to part A. Let's go to part B. Part B asks us to find the angle between line 2 and the positive x-axis, and also to find the angle between line 3 and the positive x-axis. So let's start with, I think I started with line 3. Okay, so let's draw line 3. Line 3 has a gradient of a half, so it kind of climbs slightly. Okay, gradient of about a half. Yeah, by eyesight, just about that. Okay, so if that's the gradient, we are being asked to find the angle it makes with the positive x-axis. So that angle here, that's what we are looking for. Let's call that angle alpha. Well, the angle that the line makes with the positive x-axis must be equal to the tangent of the gradient. That we are saying that tan of alpha must be equal to a half, or 0.5. And that means alpha must be arctan 0.5. Okay, plug that into a calculator and you will get that the angle is around 26, was it? It's about 26.6 degrees. Okay? Right. So that is the angle that line 3 makes with the positive x-axis. What about line 2? What angle does line 2 make with the positive x-axis? Here's line 2 with a negative gradient. This is important. Okay? All right. So I'm drawing a line with a gradient of approximately 2, but in a negative direction. So that's about -2 by eye judgment. Okay, so the angle we are looking for is the angle between, remember the line is moving to the positive direction, so we are going like that. The angle it makes with the positive x-axis is not that angle we are talking about. We are talking about that angle down there. Okay, so that is the angle it makes with the positive x direction. If we were interested with the angle above the positive x direction, we can always find it because this angle here would be 180 degrees. So if we can find this, we would be able to find that other angle there. No big deal. All right, so the tangent of angle beta must be equal to the gradient. So tan of beta must be equal to -2. So beta must be arctan -2. plug that into your calculator, and you will find that that angle down there is going to be negative 63.4. That is to three significant figures. So that angle is negative. So the negative simply means that it is below the positive x-axis. Okay, its value, its magnitude is 63.4, but it is below the x-axis. Okay. So the size of the angle is 63.4, except because of that negative there, it's telling us that the angle is below the positive x-axis. All right, that was part B of the question. Let's go to C. Question C says, show that the lines stated in part A, part 2 are in fact perpendicular. So let's say you said that line 1 and line 2 are perpendicular. Then we want to show that line 1 and line 2, the angle between them is in fact 90 degrees. If they are perpendicular, then the angle between them should be 90 degrees. So we want to show that the angle between those two lines is 90 degrees. So what do? Let's draw the two lines. So here is going to be our line. That's line 1, of course, because line 1 has a gradient of half. It would be the same if you took 2 and 3. So line 1 and line 3 might just look like that. And the angle that it forms is that, which we found to be 26.6, if you remember. You can rewind the video and see what we found earlier. And we're going to draw line 2, and line 2 is that. Okay, we found that it forms an angle of 63.4. So the size of that angle is 63.4, but it is below the positive x-axis. That's why the answer was negative 63.4, but the actual size is just positive 63.4. Okay, now what we are looking for is the angle between the two lines, and therefore the angle we are looking for is this one here. Okay, we're looking for this angle here, the angle between the two lines. Okay, to do that, I'm going to draw a horizontal line parallel to the x-axis, and if I do that, then this angle here must be the same as that angle. That angle there has to be 26.6, like this. I'm just moving that bit there. We are saying that angle is 26.6. Similarly, I can move this to that point there. Okay, and we say that angle there must be 63.4. So the total angle from down there all the way up must be the sum of 26.6 and 63.4. And so theta is 26.6 plus 63.4, which is 90 degrees. And because of that, line 1 and line 2 are in fact perpendicular. They are at 90 degrees. Okay? I hope you enjoyed that. Let's look at, I think there's a last one. Check your understanding with the example number 2. Okay? Two lines A and B have gradients of √3 and -1 respectively, which is to say the gradient of line A is √3 and the gradient of line B is -1. A third line C is perpendicular to line A, it's perpendicular to this one. Okay, there's a third line C which is perpendicular to line A. Now what's the question? The question is to state the gradient of line C. If it is perpendicular to this line, what is its gradient? Okay, part B of the question says to find the angle between line A and B. What's the angle between line A and line B? And the second part is to find the angle between C, line C, and the positive x-axis. Okay, pause the video and try it out yourself, and then we will see the answer on the other side. So let's start with A. State the gradient of line C. So question says a third line C is perpendicular to line A. Now line A has a gradient of the square root of 3. So if line C is perpendicular to it, then the gradient of line C times the gradient of line A must be equal to -1. If we multiply the gradient of line C with the gradient of line A, we must get -1. Okay, that's how we reason. So let's see. Because they are perpendicular, we know the gradient of line A is √3, the gradient of line B is -1, and we are told that line C is perpendicular to line A. So the MC times M of A must be equal to -1. Okay? The gradient of line A times the gradient of line C must be equal to -1. But the gradient of line A is known, which is √3 there. So √3 times the gradient of C must be equal to -1. So this statement is true by definition for perpendicular lines. Yeah? So square root of 3 times MC is -1, and so clearly the gradient of line C must be equal to -1 over √3. Let me put that back. So if you divide both sides by the square root of 3, you should get that MC is -1 over √3, which is what our answer is there. Okay? That was part A of the question. Part B of the question is asking us to find the angle between lines A and B. We've already done a question like this. So line A and B, sorry. So what's the angle between line A and line B? Now, line A has a gradient of √3, which is approximately 1.73. The square root of √3, 1.732 or something like that. So close to 2. So by eye judgment, we can draw a line that is about that much. So that's the x-axis and the y-axis. So then I draw a line with approximately a gradient of approximately 2. Okay, so that is line A. And I draw a line B. By the way, the angle that line A makes with the positive x-axis is going to be somewhere there. And I draw line B with a gradient of -1. Okay? Next thing I want is to find the angle that A makes with the positive x-axis and the angle that B makes with the positive x-axis. Okay? So how do we do that? I'm looking for angle alpha there and angle beta. So angle alpha, again, that is going to be the same as that there. I'll just move that. We are looking for that angle. And we also seek this angle, which we'll move there in order to find our angle theta, like that. So that angle is alpha plus beta. So if we know alpha and we know beta, we will find the angle between line A and line B. So what is alpha? To find alpha, we say the tangent of the angle must be equal to the gradient. And so alpha should be the square root of √3, the tan inverse of √3, which I think is 60 degrees. So that angle there should be 60 degrees, yes. Okay. And we can also find angle beta. Okay, so tan of beta must be equal to -1. So beta is arctan of -1. And this is -45. In other words, below the x-axis must be 45 degrees below the x-axis. There, like that. And I'm putting those two lines to indicate that we are not interested in the fact that it is below the positive x-axis. We are just interested in the value, which is 45. And so the angle we are looking for must be equal to 60 plus 45 there. Okay. For that reason, alpha plus beta is 105. So I can remove that and put 105 there. Okay. And that is the angle between line A and line B. Very, very straightforward if you have done basic trigonometric ratios. Okay. Let's go to part 2 of B. Okay, so the second part asks us to find the angle between line C, whose gradient we found, and the positive x-axis. We found the gradient of line C to be -1 over √3. Okay, and so if we want to find the angle it makes with the positive x-axis, I'm again drawing the line, the x and y axis there, and I'm going to draw a line with, it was -1 over 3, which is well, negative 0.5773 something. Not that it matters, but we know that the line is sloping downwards to as we move to the right. Okay, and so that's the line there. The angle we are looking for is that. Okay, the line has a gradient of -1 over 3. And so to find that angle, we just say tan of theta, let that angle be theta, then tan of theta must be equal to the negative 1 over the square root of 3. That is about 30 degrees, I think. Yeah, I think so. And so arctan of negative 1 over root 3, that should give us 30 degrees. So it's negative 30. The negative, it just indicates that it is below the positive x-axis, but the magnitude of the line is actually 30 degrees. Okay? And so that's how we answer these kind of questions. I hope you enjoyed it. It brings us to the end of this video. I'm hoping that you enjoyed it. Please consider liking the video and also subscribing to the channel. You can subscribe to the channel by typing Elimika Dunia on YouTube, and that will lead you to the channel directly, or equivalently you can scan directly onto the QR code, and that will take you to the site directly. Okay? Thank you very much. I will see you in the next lesson.